In this video, we'll look at factoring trinomials with the leading coefficient equal to 1. So trinomial means we have three terms, so I'm just going to write this initial example down like this. So the leading coefficient part of it, this is a trinomial again because we have three terms. And I should say quadratic trinomials because we're factoring out all of these will be quadratic. They'll have a square term as their largest exponent. And the leading coefficient is the one that's in front, so there's an implied 1 there. Now if, for example, we erase this, and we had it rearranged in the initial problem, if we had the a here and the a squared here, we would need to rearrange that so that it was in proper descending order. So this would, if you were given the problem like this with the squared term in the middle, you need to rearrange that so that it's in proper descending order. And that would put your leading coefficient up here as 1. So make sure before you start working with these that you check the problem and make sure it's in proper descending order. Okay, so looking at this one, a squared plus a subtract 20. When we factor, we're doing the opposite of what we did in the previous unit when we multiplied polynomials. So in the previous unit, we would have ended with this as our answer. And we would have started with two binomials in parentheses. That's what we started with before and we ended here. So now we're going to do the opposite. We're going to start here and we're going to end with two factors in parentheses. In this case, it'll end up being two binomials. So our process is this. We want to put a little X on our paper, and this is just a visual help for students. We're going to put whatever number is right here, so your constant term in this case, right here in the top of this X. And we're going to put whatever number is right here in front of your first power term. In this case, it's an implied 1 right here. Our goal is to identify two numbers that will multiply to that number, negative 20, and combine through either addition or subtraction to be that number 1. So we need all of the factors of 20. So we can start listing those. So 1 and 20, 2 and 10, 4 and 5, and we're done. Once you have two that are very close together like this, you're done. So those are all of the possible factors, and you can see that I need a negative 20 so I can switch these signs around in all of those different combinations. But what I'm really looking for are the two that when combined through addition or subtraction would give me 1. So in other words, which set of these are 1 apart? And in this case, that would be this, 4 and 5. So then I need to apply my signs. I'm going to go ahead and mark these out because I know these are my two. So I'm going to write them right here, 4 and 5. Doesn't matter. I could write 5 here, 4 here. It doesn't matter. Now I need to apply my signs. I need to multiply to a negative 20. So one of these has to be negative. One needs to be positive, one needs to be negative. So I determine my sign by this. I want to add to a positive 1. So worst case, when you're starting, let's say you put the negative here. Check it. Well, negative 4 times 5 is negative 20. That's good. But negative 4 plus 5 is, and negative 4 plus 5 is a positive 1 there. So that's my combination that actually works. Had I done that backwards in the beginning, that's okay. Let's say I had a negative 5 here. Well, 4 times negative 5 is negative 20, check. 4 minus 5 is negative 1, though. That doesn't match. So then I would know I need to switch my sign. So these are the numbers I need to use. So here's the pattern. Because our leading coefficient is 1, we're going to put our A and A right here. That's always going to be the case. And then we're going to put these two numbers with it. So negative 4 here, plus 5 here. It would be just fine if I put the plus 5 first and the negative 4 last. It doesn't matter. These are both equivalent. So this is the factored form of this. Now when you first see this, I understand it's confusing. But our goal is, again, two numbers that multiply to that number and combine through addition or subtraction to that number. That's what we're looking for. So let's look at another example. Okay, this one. So our leading coefficient is 1, so we can use this method. And again, I'm going to put my X on my paper like this. I'm going to put I need to multiply to negative 3 and add to 2. I need to multiply to that one, add through addition, or combine through addition or subtraction to that one. So now I'll list the factors of 3. The good news is there's only one option, 1 and 3. That's the only possibility. Those are the only factors of 3, the only numbers you can multiply together to get 3. So now I'll put my 1 and 3 there. Then I need to fix my signs. So I need to add to a 2 and multiply to a negative 3. So if I'm multiplying to negative 3, one of these has to be negative. So let's say I tried my negative right here. So check it. 3 times negative 1, negative 3, check. Negative 1 plus 3, positive 2, check. So that's it. That's the combination, negative 1 and 3. So I put my parentheses here. I put my n first in both of them. That's always going to be the case when the leading coefficient is 1. And then, now that I've identified these numbers, I put those in the parentheses. So subtract 1 plus 3. Again, it doesn't matter the order. I could also do it this way, n plus 3, n minus 1. When you multiply, order doesn't matter. Just basically, if 3 times 2 is 6, well, 2 times 3 is also 6. When you multiply, the order doesn't matter. You could put the 3 first or the 2 first. Same principle here. It doesn't matter which factor you put first. So the factored form of this is either answer here. All right, number 10 is going to be a special case. We don't know that it's a special case in the beginning, so we still follow our process. So I see that the leading coefficient is 1. It's a quadratic trinomial, so I'm going to use the process we've set up. So I'm going to put my x on my paper. I want to multiply to negative 15. I want to add to 3. That's my goal. Multiply to negative 15, add to 3. So, factors of 15, list them out. We have 1 and 15. We have 3 and 5. And that's it. Those are our only options. So, I can put, now I need to check which one of these would give me a 3. Which one are 3 apart? Well, this one, if I combine that through addition, I either get a 14 or a 16. If I add them, I get 16. If I subtract them, I get a 14. That won't work. Here, 3 plus 5 is 8. 5 minus 3 is 2. That doesn't work either. So if none of the factors work here, then you just say it's not factorable. And sometimes they're not. So that one would not be factorable. Now be careful and make sure you've checked all possibilities before you say this. But if you check all possibilities and none of them work, then you can say this one is not factorable. And in fact, that is true on this one, not factorable. So just be aware that there are some quadratic trinomials that are not factorable. So let's look at one more example. All right, number 12 here. There's one thing that when we're factoring, and we always need to do this every single time, we always want to first look for a greatest common factor. And we did that actually in the previous lesson. So we should be used to that. So if I look at the coefficients and the constant term here, I can divide a 3 out of all of those. As far as the variables go, I have a k squared here and a k here, but I have no k right there. So I can't take a variable out, but I can factor out a 3. So when I do that, I'm left with k squared plus 8k, and then negative 60 divided by 3 is negative 20. So I'm left with this. When I am factoring, once I have taken out a greatest common factor, I have to look at what's left, so this part right here, and see if it will factor. So I need to follow my process with this and see if it will factor. One thing you must keep in mind, if you factor out a greatest common factor, you must write it in each step. So I can't drop the 3 down here in my final answer. I must list it as well in order to be correct with my factoring. So, put my x on my paper. I want to multiply to a negative 20. I want to add to a positive 8. That's my goal. Multiply to that one, add to that one. So factors of 20. So 1 and 20. That's not it, because if I combine those, I get one of two things, either 21 or 19. So I need an 8. That won't work. 2 and 10. That either gives me a 12 or an 8. So that's a possibility. Then 4 and 5, those are my only options. So 4 and 5 gives me either 9 or 1. So that's not going to work. 19 and 21, those aren't going to work. This one is it, because 2 and 10 will give me an 8 if I combine the signs correctly. So I'm going to put 2 here and 10 here. Remember, I could put 10 here and 2 here. It doesn't matter. Now apply your signs. So I want to multiply to a negative 20, so one of these has to be positive, one has to be negative. In this case, it's going to have to be this one. One rule of thumb when you get to this point, if one of these signs has to be positive and one is negative, the biggest one of the two wins whatever sign's right here. That's one little trick that you can use, and notice that's true here. The 10 won the positive. Whatever sign's right here, the bigger of the two will win that sign. But you can check it. Negative 2 times 10, negative 20. Negative 2 plus 10, 8. Check. They both work. Now, put the 3 out in front. Don't forget it. Put your 2 sets of parentheses for your factors. We're using k as our variable, so k and k. That's always the pattern. And now just put these two numbers in. So subtract 2, add 10, done. Again, it is fine if you wrote this. K plus 10, k subtract 2. Either way is fine. So this factors to this or that. The order doesn't matter. Okay, that's it for this video.